This is a CBC podcast. Hit the great outdoors with the Extreme Canada Summer Podcast Series. Every week, host Paul Karchett tries a new fringe sport, like street luge, bull riding, and freediving. Go to cbc.ca/Extreme Canada to download the podcast. Watch unbelievable videos of Paul's adventures, and enter the weekly giveaways for Mountain Equipment Co-op gear.
It may come as a surprise to many of you, but there are glaciers in Labrador, and they are some of the most southerly glaciers in the world. Robert Way is from Happy Valley Goose Bay, and he's one of the researchers right now up at the Torngat Mountains National Park, taking a closer look. I spoke to him before he left for the park and asked him what makes those glaciers so unique.
I think one of the most important things to consider about the glaciers there is that they're the furthest south in the eastern Canadian Arctic. And so they kind of exist at this boundary between where glaciers can exist in the Arctic and where they can't. And so that's one of the things that makes them so unique for scientific inquiry, because especially with things like climate change, this boundary can shift north, and the result is maybe regions that used to be able to retain ice no longer can. And that's one of the reasons that it's very important for us to be kind of investigating them. And aside from that, there's also that these glaciers exist very low in the mountains. There's ones that are very high, but there's ones that are also very low. And that's different from in a lot of regions of Canada. When you think of Western Canada, you think of these glaciers which are very high up in the Rockies. But in the Torngat Mountains, you get glaciers that are much lower in elevation than even the Mealy's, right? And so that's more like you would find high up in the Arctic. And that's one of the other things that makes them very interesting, certainly.
What is it about the conditions that allow the glaciers to be so far south?
Compared to other regions, it's actually not as far north as people have the impression of it, but yet it's very cold and it's very northerly. And I mean, you know, some of the lowest northern tree line in Labrador is actually much further south than it is in the Yukon and places like that. And the reason is because it's a lot colder, we get a lot more snow than perhaps other regions in Canada, and that's one of the other reasons they're able to survive, is because the temperatures are so low in Labrador and because we have such abundant snowfall.
How many glaciers are there up there?
In total, we have inventoried 124 glaciers.
Wow.
Yeah, it's quite a number. Originally, there had been inventories done in the past that had the number much lower, but we finally just completed the full inventory, and we have 124 glaciers, and this was based in 2005. Now, there may have been changes since that time, but in 2005, there was 124.
How big are the glaciers that we're talking about here?
From a size perspective, if you look at the soccer pitch up here on the base, that's roughly the size of our smallest glacier, and our biggest glacier is roughly 80 times that, with the average one being 10 to 12 times that size.
So these aren't the giant glaciers that you often see in the Rockies or when you think about, and you see pictures on TV.
No, they're very different from those glaciers that you would see, and one of the big reasons is obviously they're at a lower elevation. The mountains aren't as high there. If you had mountains that were 2,000, 3,000 meters like you have in the Rockies, you would see bigger glaciers because they have more area to be fed from ice and snow.
Tell me about the changes. What sort of changes are happening with the glaciers there?
Well, we've only just begun monitoring the changes as part of the Torngat Mountain Glacier project at Memorial University. But one of the things we can tell you first off is that we have preliminary results from change between 2005 and 2007, and we see an overall decrease in area of about 3%.
That's a lot for a fairly short period of time.
That's the thing. I mean, when you hear a number like 3%, it's like, oh, that's not that much. But then when you think a decade, that's 30%. So that's actually quite a rapid decline. And the question is whether it continues or not, because we have such a short period of observation. And that's one of the reasons that it's important for us to continue to go up so that we can make these measurements and be able to determine if that's just short-term fluctuations or a long prevailing trend.
And I guess it's hard to have any sort of long-term data when there are a bunch of glaciers we didn't even know existed before this inventory, let alone what condition they were in 50, 100 years ago.
Well, one of the advantages is during the 1950s, there were a lot of aerial photography surveys in the region. And so one of the things that we've been doing the last few months is getting a lot of aerial photos from the 1950s covering the whole region. You have to get them from the National Air Photo Library, and so we've been trying to acquire them. And that actually will give us the opportunity to at least see how they've changed area-wise over that period of time. Now, there's only so much you can say from area because the more important measure is the volume and how thick they are. But you can make general approximations that if they cover less of an area, you have less ice, right?
What is the next step for the research?
It's kind of threefold. One of the things I will particularly be dealing with is we're going to go up there and try and map where glaciers used to be, not just 50 years ago, but 200 years ago, 300, 400 years ago, because glaciers tend to leave remains of where they once were, where their maximum advance was. And by dating the vegetation on these moraines, they're called, they're just more or less ridges of sediment that were left by the glaciers, you can tell how old they are. And so that's one of the purposes of going up this summer is we're going to try and date a lot of these moraines and get an idea of where they were perhaps 300, 400 years ago.
So you know how far back the glacier
Yeah.
is now, and you've got an idea of whether or not this shrinking is a recent thing or whether or not it's been happening for years.
Yeah, I mean, we could go up there and see that those features are actually much older or much younger because we really don't know beyond what we can say from the aerial photos, right? We can make approximations based upon, the rate that we've observed elsewhere, and you don't expect that they're going to retreat ridiculously faster than other places or ridiculously slower. It should be relatively uniform, but that's one of the reasons you investigate because they are unique in a sense anyways. So we won't be surprised if we see different results, obviously.
Well, interesting stuff. Thank you very much for coming in and telling me about it.
No problem.
That's Robert Way. He's from Happy Valley Goose Bay. He's up in the Torngats as part of his master's research.
Looking for more CBC podcasts? Go to cbc.ca/podcasting.